Welcome back to Oster Oncology. This is Dr. David Oster, and in today's video we will be discussing how your own immune system responds to foreign invaders, keeping you safe from infections. In particular, what we will focus on today is how your immune system responds to viral infection. So that can be rhinoviruses, influenza, coronaviruses as well. So you're going to see how the cells of your immune system are designed beautifully to work in concert together to respond to these foreign viral invaders. Your bone marrow makes these cells, so it's the origin of all of the circulating cells of the body. So the red blood cells, as I'm drawing here, of course that's more involved in oxygen circulation through the body, but we will be focusing on this next set of cells, which are your immune cells. We call them the white blood cells, or leukocytes, leuko meaning white and cytes meaning cells. So the white blood cells, we'll focus on those today. Also of clinical relevance is your platelets. So I'm drawing your platelet counts here, and depending on perhaps chemotherapy that you're on, your platelet counts can be impacted as well. But today we are going to be focusing on the white blood cells. So there's certain types of white blood cells that I'm going to highlight for you today, show you how they work together, starting with your T cells. These are also called lymphocytes. They spend a lot of time in the lymphatic system, your lymph nodes, as your B cells do as well. They are both called lymphocytes. We'll also be looking at the antigen presenting cells. So they actually present the problem bug to the rest of the immune system. You'll see how that works. T helper cells are intimately involved as well, and then granulocytes. The cells above are actually called agranulocytes, but there's a certain type of white blood cells called granulocytes, and particularly your neutrophils are of profound importance to the immune system. They do the majority of the heavy lifting to protect you from bugs, and they actually contribute the majority of the head count for your leukocytes as well. About 65% of your circulating white blood cells are actually neutrophils, and you'll see them in action today. But to start with, I want to show you how the antigen-presenting cells start this cascade of response to a viral infection. So the antigen-presenting cells, when they are exposed to a virus, as you see within the cell there, this is the antigen-presenting cell, it cannot kill the virus itself, but what it does, it quarterbacks the rest of the immune response. So it will, by its name, present the viral protein to other cells in the circulation. So you see here it presenting the viral protein, a component of the virus, to a T helper cell. And they are marked by CD4. It's a way to identify T helper cells from other immune cells. Now, when T helper cells are activated by the antigen-presenting cell, they release a group of compounds called cytokines. And it's the second event here. And cytokines are cyto meaning cell, kines meaning movement, like kinetic energy. Cytokines are released by the T helper cell. And another component to the T helper cell, which is really important, is the characteristic, the quality that it can develop memory to what it has been shown by the antigen-presenting cell, which is vital for your long-term immunity against that virus. So that's one of the ways your long-term immunity is established. T helper cells are not the only cell type. You'll see today other cells can develop immunity as well, so that you can have this lifelong immunity and quick response when you're exposed again and again, perhaps to the same virus. So the next event along this cascade is the activation of another group of cells, and these cells are called T cells, or more specifically your cytotoxic, which means they can kill cells. So the T helper and the antigen-presenting cell cannot, but these cells can actually kill and destroy infected cells. So these are your T cells, and they, once exposed to these cytokines, are then activated to this same viral protein. The response to this is that the actual increase in number or the proliferation of this group of cells. So you get more circulating cytotoxic T cells, and not only are they increased in head count, but they are actually jazzed up and activated to attack any cell that has been infected by this particular virus. So you'll see here that they can therefore circulate through the lymphatics and circulate through the circulation and kill the infected cells as well as the virus itself. So that's the first sort of chain of events. Memory here. So the cytotoxic T cells no longer always need the antigen-presenting cell to start this cascade, but they can respond even more quickly once they have been activated the first time. So they have memory and immunity as well. Okay, so we're going to pull in the neutrophils here and how they work in concert with the antigen-presenting cells. So once again, just like the previous illustration, we start with the antigen-presenting cell presenting the viral protein. But this time it's not to the T helper cell. We're also going to pull in the B cell at this point. So you will see the direct communication and presentation of the virus to this other group of cells called our B cells. Now, B cells are vital for memory and immunity as well. So again, it's a quality. You can see the multiple levels of memory and immunity that we can develop against these viruses. In response to the presentation of the virus protein, B cells make antibodies. Now, antibodies are small molecules. They're smaller than cells, but they are released into the circulation. They have this sort of Y shape. Actually, the molecular structure, they look like Ys. And they label foreign invaders. So this virus is not inside a cell. It's actually in circulation or perhaps on a mucous membrane, and the antibodies will then bind to it directly. And that virus is forever moving forward labeled as a problem. And neutrophils are very well designed to engage and interact with anything labeled by an antibody. And they have actually a very interesting nucleus here with the DNA in it. It's sort of lobular, as the others are more singular nucleus, as you see in the other cells. But the neutrophils, they look really different. But they, once they see a labeled foreign protein, they ingest it, actually, and kill it and dismantle it. So that's how your neutrophils work alongside your B cells with the antigen-presenting cell. Now, a question arises, how can we enhance this? Do we have any ability to boost this, to optimize this type of response to viral invaders? And the answer is yes, there's a lot you can do. Based on the evidence, published evidence, we know that vitamin D optimizes this system. There are certain minerals that we know, zinc and selenium in particular, have an antiviral enhancement of the immune system. There are certain botanicals, certainly elderberry, echinacea, ginseng, astragalus. There are many herbs that we know can enhance your immune response to viral invaders. Also mushrooms, Coriolis, maitake, reishi, chaga, the list goes on. All of them can really jazz up your immune system as well. And then two key elements that we all need to be aware of is sleep. Melatonin directly, but also just, are we sleeping well and are we exercising? Because we know both of those are fundamental to have a strong immune system. So I wanted to share this with you today. In the current place we find ourselves, coronavirus fears and so forth, I really wanted to encourage you. You have an immune system that is beautifully designed to respond quickly, efficiently, on multiple levels, to respond and kill viruses, and also that there's a lot that we can do to enhance its function so that you can have a strong and healthy immune system. From Oster Oncology, fight stronger and fight smarter.